6-4. We are going to find confidence intervals.
7.
Did you turn on your microphone?
I did. Thank you.
Anything for you, Shorty?
Oh, thanks. For population variance. Do you remember the symbol for population variance? It is sigma squared. And population standard deviation, which is just sigma. Okay. So, the key things here is that the data that we're taking, we might be taking averaging weights or averaging heights, but then we're going to look at the standard deviations. Remember how we run one-bar stats, we can get mean and standard deviation? When we do the distributions, this is the key stuff here. The distribution for variance and standard deviation will always be skewed right. If the population is normal. Okay. So, our critical values, when we found z-scores and then when we found t-scores, those were our critical values that we were finding. Here with variance and standard deviation, the critical values are chi-square values. Chi is the Greek letter, square values. And chi, the Greek letter chi, kind of looks like a big old X, capital X. So it's
Like loop thing?
Yep, with that little loop thing.
Oh, okay.
So it's chi-square. That's the symbol. We have z's, we have t's, now we have chi-squares. And it's just the Greek letter that goes with the critical value for this skewed right distribution. So, our distributions for variance and standard deviation are going to look like this. Oops, I smeared that a little bit. Skewed right. Our confidence level is going to be in the middle. That will be our area in the middle. And what's going to happen is we are going to have to find our chi-squared left value and our chi-squared right value. These are not symmetrical like it was with z's and t's. Usually it's positive and then the equal but opposite number. Not so here. We've got to read a table for this. So our first example is going to be getting our critical chi-squared values that are going to go into our formula. I know.
I'm feeling the English language just kind of nipped off
Off the Greeks? Kind of looks like it. So, our first example is going to be reading the chi-squared table. Find, oh, I did forget one thing. Oh, sorry. DF, degrees of freedom, sample size -1, just like it was before. Sorry. You can squeeze it on the side there. I know you've got room. Find critical values, in other words the chi-squareds, for a 95% confidence interval.
Like, don't grade me on my content.
Okay.
Is that X too?
Yep, that's chi-squared.
But we don't, oh, we just put the lead.
Well, it kind of is there. It's just closed up a little bit. With sample size n equals 25. So the table, and there is no function on, even the newer calculators don't have chi-squareds built in, I'm pretty sure. So you have to use the table. The chi-squared table is on page, it would be an inv chi, you can check, page A21. A21.
Where is A?
In the back. And chi-squareds are based on areas to one direction or another, and we'll talk about that. A21.
No. No. Go away.
Okay. So, if you take a look at the columns on your chi-square, you've got degrees of freedom down the left, and we get degrees of freedom from sample size minus 1. And then we've got all these percentages along the top. Okay? So I'll tell you, if you look up here, what part do they have shaded? Oops. To the right. You're going to need to know the total area to the right of the chi-squared value.
2.848.
So, let's go back and make our graph, because we need to find two chi-squared values.
Oh.
Make the graph. And I don't care that you make it skewed right. It doesn't really matter if you made it look normal. I wouldn't care. Yes. So what we know is in between these two chi-squared values is our level of confidence, 95%. So then what's left over is the 5%, and we divide that evenly between the two tail pieces. So that means this tail piece is 0.025, and this tail piece is 0.025.
Quick question.
Yes.
Why?
Why? Because we got 5% left over. 95 used up there, lose 5% of the graph. Divide it by 2, you get 2.5% for each one. So when I add all three of those up, I get 100%.
Okay, because in my head I put 0.5.
Oh.
Okay, got it.
Okay. So if I want to find this chi-squared value, this is called the chi-squared right, because it's on the right-hand side. You need to know your degrees of freedom and your area to the right. So for this chi-squared value, how many degrees of freedom does this problem have? 24 degrees of freedom?
Yeah.
Degrees of freedom, n minus 1. So go down.
So n is now degrees of freedom?
No. N is the sample size, and it's 25. What's 25 minus 1? So my degrees of freedom is 24. My n is 25.
I'm telling you 13.4.
Okay, so I'm going to go down to 24, and then go over to that 0.025.
0.025. Never mind. Don't hit.
Okay,
39.364.
39.364.
Wait, why did you do 0.025? Because of the
Area to the right. For the chi-squared, you got to look up area to the right.
I don't know.
So this one here, we're looking up the 0.025.
That's final answer.
Oh, we got to find the other one. 39 point, what was it?
39.364.
364. Okay, now I've got to find the chi-squared left value. This one back here. So I need the total area to its right. How much total area is to the right of that one?
0.95 plus 0.025.
Correct. So how much total area is that?
0.975.
0.975. You got to add the total area to the right.
12.401.
So if you go down to 24,
Wait, why is this number smaller?
because it's a number line starting from 0. Yes, I should have told you that. This number line starts at 0, so this one should be smaller. As it gets out to the right, I go bigger on the number line. And what'd you say it was?
12.401.
12.401. Everybody have a chance to find that?
Yep. Okay, mine is here.
Okay. We're still at 24, correct? And I need if I want this chi-squared value, I got to look up the area to its right. So if there's 2.5% behind me, what's the total area to the right of this thing? You got to add those two together. 95 plus 2.5 is 97.5. So if you look along the top, you have a 97.5 right here, 0.975. And you go down to the 24 degrees of freedom, and it's 12.401. And we'll be doing this at least 2 more times, so. Okay, so 12.401. Okay, if you can do that, now it's just use the formulas I give you and it's easy. Okay. All right, so these are really confidence intervals.
How long do I do?
I'm going to write this right here, these 2 formulas. So this is what's coming at you.
Oh my god.
Confidence intervals for population variance and population standard deviation. We don't have a program for it, we only have it by hand. So the variance formula you're going to take n minus 1 times your sample variance divide by the chi-squared right value. That'll give you the low end of your confidence interval,
Wait, what does that say? S squared?
S squared.
What is that?
S is the sample variance,
There.
or it's the sample standard deviation squared, which is variance.
Oh.
N minus 1 times the S squared over that chi-squared now left. That will be your confidence interval. Just plugging into those 2 things.
Hold on.
Okay, notice the right and left got switched here?
Yeah.
Because the bigger number, if I divide by a bigger number, it makes the fraction smaller. If I divide by the smaller number, it's going to be bigger. So it's going to make it the small to the big. Okay, and then standard deviation interval. What's the symbol for standard deviation? Population. Just sigma. So if this is variance, where it's sigma squared, how do I get it down to just sigma? How do I get from here?
Square root of them.
I'm just going to square root those 2 answers. And then I'll have the standard deviation interval.
Are you driving down that?
I am going tomorrow morning at like 4:30 a.m. Yeah, that's sick. No, I had a room and then Andy's got a meeting tonight, so it was, oh, nice. We'll leave at 4:30 then. Happy about that.
Yay.
Yay! So, oh, that is the plan. Okay.
Your lovely hubby.
Yes. Here we go. We're going to do 2 problems. One, and you'll see why.
So is it just like the n minus 1 s squared shenanigans?
Yep, it's under, just take the square root of that stuff. So it's a pretty easy process. as long as you can read the table, this is real easy. So example 2.
Whoa, whoa. Wait,
Yes.
just wait.
What's the baby thing, please?
Okay, here's our first example.
Is it on?
Just gotta write it out.
What? This one is like.
Or try it number 2. Okay, we're going to randomly select 30 allergy meds. The sample, and you're going to weigh them. How much medicine, the weight of the pill.
Are we writing these formulas out?
No, not yet. Just write down the problem. The sample standard deviation was 1.2 milligrams. Yep. I got that a little bit big here. There we go. 1.2 milligrams. Weights are normally distributed. We want to find the 90% confidence interval for population variance. Okay, so again, when the test comes up on Tuesday, you want to know what are you finding the confidence interval for. Is it a mean? Is it a proportion? Or is it a variance or standard deviation? We are finding the confidence interval for variance. That tells you to come to this section on your note card. That's the key. So now all I've got to do is plug into these two formulas here. So I need to know what n is, I need to know what s squared is, and I need to know the two values from the table. So let's see if we can just identify those things off to the side. What is my sample size? 30. They gave me the standard deviation was 1.2. What symbol goes with sample standard deviation?
Little s.
Just little s. So that means S is 1.2.
The f is
So
49.
So now we've got to read the table to get these two chi-squared values. I like to make the little graph so I can write the areas on there and then look them up. I need this chi-squared value and I need this chi-squared value. How much area do I know is in between those two chi-squareds? How much area is in between? 90%. What does that leave for each tail piece? 5%?
5%.
And 5%. Okay, now you got to read your table on page A21. Let's find the larger of the two chi-squareds, the right one. Remember with chi-squareds, it's area to the right. How many degrees of freedom for this problem? 29, one less than the sample size. So we'll go down to 29, go over to the 0.05. What's that bigger number?
42.55.
And we're in agreement there. Now we need the other chi-squared value. The smaller one. This one should come out smaller. How much area is to the right of this value? Total area to the right is how much? 95. Yeah, I want to know it.
17.708.
Are we in agreement? Okay. So now we just got to plug into our little formula at the top, and then we'll have the confidence interval after we crank through the calculator. So, using my formula at the top, because I want for variance, that's the sigma squared one. So, look at your formula. I need n was 30 minus 1 times the s, which was 1.2 squared, divide by, it says chi-squared right. What number's going underneath this first fraction? The 42. The bigger one goes under here. And then 30 minus 1, 1.2 squared, the top's the same, and now we divide by that 17.708. And we get those two answers.
Who came up with this?
I have no idea. Isn't it crazy? And now it's just calculator work.
What are exactly the results?
We are finding the confidence interval for the variance of the medicine. How much it varies, how much the pills vary in weight by.
Wow. Okay, I have a question.
Yes.
Where it says n minus 1,
Yep.
why don't we just write degrees of freedom in it?
You absolutely can. You absolutely can.
That's so much more work to put n minus 1.
Oh, I know, it's killer.
I'll just do it in your head before you type it in.
Yep, you can always do that too.
Oh my god, please don't ever tell anybody I just said that. That's okay, it's still very low.
It's actually pretty hard to hear, so.
I haven't listened to it, so.
I was listening to it one day and we were all I heard.
The topic about sex came up quite a bit.
All right, what are you coming up with for the low end here? Anybody? 0.981?
That's all, yeah.
Okay. So that's how many milligrams. And then the upper end? Are we in agreement with 2.358?
Yep.
Okay, so that's the interval for variance. What if I had said find it for standard deviation? What would you do now?
Take the square root of
Just square root both of those and be done.
Wait, so instead of like putting the square root into like the calculator with all the junk up,
Mhm.
you just square root.
Square root these two answers will be much, much easier.
This actually isn't bad, right?
Isn't bad.
Would it be accurate?
It would be, yeah, accurate enough for me.
Wait, that's the answer?
That's the answer.
Yeah.
So if you can read the table and understand what's given to you, it's not bad. I'm going to do one more just because I'm going to change one thing up, and we'll see if you're...
I don't know.
Yes, you get the book for the tables. Yeah, absolutely.
Why aren't we doing this one?
Which one? I'm going to do it in the next one.
Never mind.
Okay. Here we go. So here we are going
Is
to...
this like the same length as the other one?
Yep, same same length as the other one. All right, so this one, we want to go with...
Oh my god, for you. Sacrifice in my dreams for you. In your dreams.
The critical, let's see. I'm going to make something up here. Give me...
I don't know if it was a dream. I looked at
Select
Yeah, you still watch it?
Big
26.
potato things. Potato things.
Yeah, I know, but you said it's Sriracha, I don't know what that is.
It's like Asian.
Let's see, they have 26 CD players. We don't even make CD players anymore.
I don't,
They're irrelevant.
What did you just say?
Select 26.
CD players.
I started making that case.
The variance of the prices
Hey, I'm sorry. Sorry for being American? No, I've never.
was 2.25 squared dollars. Yep, because it's variance, that has units squared.
What?
I remember we talked about right at the beginning how,
You're there.
Oh my.
well, it's by the dollars. It's by the, dollars is like the only one where we put the label in front of the number.
So we wouldn't square
No, it already is dollars squared. It is the variance.
What are you saying? What?
Just go with it. Just go with it.
Just don't ask questions.
Know that this number here is the variance of the sample
If
prices.
you just write out 2.25, then write out the word dollars and then
Squared.
squared.
Yep, maybe if I put it on the end, you'd like it dollars
Just write
squared.
dollars squared.
Okay. Find the 95% confidence interval for population standard deviation. So this time I'm finding the interval for the standard deviation, which is still in this section. So that tells you to come to this section. So just like before, we need to know n, s, and then the two chi-squared values off of the table. So sample size is 26. Now, this thing that Michaela was stumped with, what's the symbol for this variance that I'm giving you? This is the sample variance, because it's coming from these 26.
Sigma squared.
Not sigma, because it's sample.
That's squared.
This is s squared.
Yeah, but we don't want S.
Well, let's write it down as what the s squared is 2.25.
No, we don't need. I spelled like Stephanie Schwartz.
You see where I'm going?
So are we just square rooting that to get at?
Well, you could, but then it's going to take you right back. Just hold on. And now we need our chi-squared values, so we'll make the little table. You got your chi-squareds. You got your area in the middle. And you have to figure out the area in the two tail pieces. And at this point, these should be getting very easy. 0.025. 0.025. And now you use your table. This is the only place you can really screw it up. How many degrees of freedom we got going on in this one? 25. And then if you read over to the 0.025, what are you finding?
40.646.
And now the left one, which is going to be smaller, you're going to look up under the 0.975. And what are you getting there? Okay. So now this time I want the confidence interval for the standard deviation. So that's the one that has the square root in it. So the standard deviation interval will be the square root of those formulas. Okay, and our formula is still the same. N minus 1. 25. Then what does it say I want to multiply by? S squared. Do I know what S squared is? Yeah, it's already been squared for me. S squared is 2.25. So don't put another squared here. Does that make sense? And then this one gets divided by which of these two chi-squareds, the 13 or the 40? The 40. And then the other one's the same on the top. With a new, with the 13.120 on the bottom. And then it's calculator work. And I'm going to find some problems for you to do. Okay, we don't need to do a lot of these here. Let's go with page 288. I'm not going to kill you with these. How many do you think you need? Like 3?
Yeah.
I would think so. And they have you do both of them, but all it is take the square root of your answers, so it's not like it's extra work or anything. I'll pick out 3.
These are pretty easy.
Yeah, I think these will be okay. So let's go with,
Credit for not skipping the
I don't know if it's an official skip day yet. He didn't come through with it.
Only 11 people are gone.
Oh, see, it won't be an official skip day then.
They're just,
Let's see. Let's go with number 9. Oh, I don't know. I'm not a calculator. Do you want? What'd you get?
so I came here.
1.18
1.18.
and 2.07.
Are we in agreement?
I didn't do
Did-
that, Matt did.
Matt did that. Anybody else take the time to do it? Okay, I heard some yeses. So we'll go with 9.
What'd you say?
11.
11.
Let's go with, but they don't ever give you a variance. Sample standard deviation.
There's like no one here.
Let's go with 16. Just 3 of them. How's that sound?
Great.
Yep.
Yeah, they sure was.
Alright, well, I'm not sure how this is going anyway.
Did I give them 19 days? 14 days?
Okay, shut this off.